So this is the second half of section 7.6. Solving log equations. So again, we saw that when we were dealing with exponential equations and solving those, there were two different types we could run into. There was the type where we could equate the bases, and there was the type where we couldn't equate the bases. If we could equate the bases, we did so, and then we rewrote the equation in a way that we could actually solve it. If we couldn't equate the bases, what did we do? Took log of both sides, right? Either log base 10 or log base e, depending on whether there was an e in the problem or not. Okay, well now with solving log equations, now we're going to start with logs in our original equation. And again, our goal is going to be to change it into the other form. So we're going to want to get rid of our logarithms. And there's a couple ways to do that, depending on which of the three flavors we are facing. So there are three different types of these problems, basically. So type 1 is a log equal to a number. Type 2 is a log equal to a log. And then type 3 is going to be multiple logs, 2 or more. So I'll put greater than or equal to 2 of them. Right? You could have 3, you could have 4, but you have at least 2 logs and another number. So these are the three types that we're going to talk about. So get those jotted down, and then we'll talk about each type one by one. So the first type is a log equal to a number. For example, log base 2 of x plus 1 equals 3. And we want to solve this for x. First thing that you need to do, guys, is you need to get the log all by itself on one side. Because we're going to unravel this thing to change it into an exponential. Okay, just like when we were graphing log functions, right? Before we could unravel it, we had to get the log all by itself. Same idea. We cannot unravel it until the log is by itself. So now I can unravel this thing. Well, for example, if this was a 2 and this was a 6, what would we have to do first? Divide everything by 2, and that would get us back to here, right? So that's what I mean by get it by itself first. Now notice we don't have to move the 1 over because the 1 is part of the logarithm because of the parentheses. But if there were no parentheses here, what would we have to do first? Good. We'd have to subtract 1 first, right? Okay. All right. So now this is by itself, so we're going to change this into exponential form by unraveling it. What am I going to get when I unravel this? 2 to the third power equals what? Equals x plus 1. So 2 raised to the third power equals x plus 1. What is 2 to the third power? 8. So we get 8 equals x plus 1. What do we do to get x by itself now? Now we can subtract the 1, which gives us x equals 7. Now, any questions about that, guys? Is that easy enough? So a log equal to a number is very, very straightforward and easy. You make sure the log is by itself. If it's not, you get it by itself, and then you just unravel it and you go from there. But you're not done. Unlike exponential equations when you're solving them, log equations have another step that you absolutely must do. You must plug it in and check it. See, exponential equations are nice, guys, because we're allowed to plug anything we want in as an exponent. The problem is logs aren't as nice in that way. We can't plug anything we want into a logarithm. What are we never allowed to take the logarithm of? Negatives or what else? No, we can do fractions, as long as they're not negative fractions. 0. We cannot take the log of 0. right? You can only take the log of positive numbers. So the question is, if I go back to the original and I plug x equals 7 in, will I be taking the log of only a positive number here? Yeah, it'll give us log base 2 of what? 8. So log base 2 of 8, the 8 is a positive number, we're okay. But what would happen if you plug this back in and it gave you the log of a negative number? What would you have to do with the answer? Throw it out. It would be extraneous, and so then you would get a no solution in this case because your only answer you had to throw out because it doesn't work. It doesn't mean you made a mistake. It means that it was a solution of the algebra equation, but not a solution of the logarithm equation. The algebra equation, x can be anything. The logarithm equation, that's not true. X has to be bigger than -1 here. That's something you'll talk about in math analysis, finding domain of these things. All right, questions about that? What do you mean the difference of those two? So you have to do this, and you have to check to make sure what you're taking the logarithm of is not going to be negative or 0. If it's negative or 0, you can't do it because it won't work. You won't get a number at all on the left side. And we'll see one that happens to in just a moment. All right, let's look at another one. Let's do log. Let's see if I can find a nice one here. Let's do log base 4 of 5x minus 1 plus 7 equals 10. So what are we going to have to do first here? Subtract 7. Good. We have to get the log by itself. Notice now we have a log all by itself equal to a number. What do we now do? Unravel it. What does it give us? 4 to the third equals 5x minus 1. Very good. Now what's 4 to the third? Good. Now what? 5x equals 65. Now what? Which gives us x equals what? Now we're not done. We have to check the answer. So if I plug a 13 in here, what's 5 times 13? Minus 1? 64. It's a positive number. Okay? So we're okay. It's not going to cause a problem. Now, if you finish checking it, 4 to the third power equals 64. So this is really a 3 plus 7 equals 10. It works. But you have to at least check to make sure that you're not going to have to throw the answer out because it's extraneous. Does everybody see that? All right, questions about that one? All right, that's type 1, a log equal to a number. Type 2, log equal to a log. So let's say we have log base 2 of 3x minus 1 is equal to log base 2 of 8x plus 9. Everybody with me? Notice we have a log equal to a log. Now, sometimes what this might look like is it could come like this. Sorry. What I would do here, guys, notice that's a 0, not another number. It's just a 0 over there. What I would do is I would add this guy to the other side till you got this. Everybody see that? So if we have just a log equal to a log, this is really nice when we can do this. Stop and think about this for a moment, guys. If log base 2 of some number equals log base 2 of some other number, what do you think has to be true about this thing and this thing? They have to equal each other, don't they? There's no way that log base 2 of 5 can equal log base 2 of 7, right? Because 2 to 1 power equals 5, but 2 to the same power won't equal 7. It'll equal 5 again. So these two now have to be the same. So this is really easy because it means that 3x minus 1 has to equal 8x plus 9. Can we solve this? Absolutely. Subtract 3x. and add 9. I'm sorry, subtract 9. Subtract 3x, subtract 9. That gives us 5x over here. It gives us negative 10 over here. So what is x going to equal then? X equals negative 2. And we're done, right? No, you must check your answer, and here's why. If I take log base 2 and plug a negative 2 in there, what's 3 times negative 2? Negative 6 minus 1. This gives me log base 2 of negative 7 equals log base 2 of negative 16 plus 9 is negative 7. While those seem to be equal, guys, are they equal to each other? No, because they're not numbers. If you punch in log base 2 of negative 7 into a calculator or a computer, you might have to change a base formula, and if you're taking it into a regular calculator, log of a negative number does not exist. It's not a number. There's no way a non-number can equal another non-number. Only numbers can be equal. So therefore, I didn't even have to do this one. As soon as I saw this, I know to throw this answer out. And since it's the only answer we got, what is our actual answer going to be? No solution. So do you see why you have to check for that? It's an extraneous solution. It does not work. Not because we made a mistake. It is a solution of the algebra here. It's not a solution of the logarithm in the original.
Yeah, so if your x is a negative, but like, if you plug it in and it's a positive,
right. It doesn't matter whether this is positive or negative or 0 or whatever it is. What matters is what happens when you plug it in. That's all that matters. Right. So if it's negative, but when you plug it in, it becomes positive inside the log, you're fine.
All right.
Yeah. And that's why you have to actually plug it in. Good question. Other questions about that one? Okay, so that's number 2, a log equal to a log. Type number 3 is multiple logs and another number. And I should say another number other than 0 to be correct. Right, because we had 2 logs and another number. That number was just 0 on the last one, on the other way of writing it. Okay, so what we're going to look at now is we're going to look at this one. Oh, no, that's okay. I already talked about that. Okay, so log of 2x. What base is that? Good, base 10. Plus log of x minus 5 equals 2. Notice we have 2 logs and another non-zero number. So there's no way for me to get one log equal to the other log, right? Even if I move it to the other side, that other number is going to get in the way. Does everybody see that? That 5 will be in the way. So what I do is I get the logs on one side. And the number on the other side. I already have that, right? But if one of the logs was over there, I would bring it back over, add it or subtract it to move it over. What we now do now we condense the logs. Notice, guys, we have a log plus a log. This becomes log of what? Nope. Yeah, 2x times x minus 5, right? The addition between the logs means when we squeeze them together, we have to do what with the numbers inside? What happens to numbers inside if the 2 logs are being added and we're squeezing them together? Multiplication, right? That's our product property. So again, this is why you have to know those properties and you have to know how to condense. So we condense those down. Now when I simplify this, this is now log of 2x squared minus 10x is equal to 2. Do you guys see what I did? I condensed my 2 logs together, equal to my number. Do you guys see that now this is type number 1 instead of type number 3? This is just a log equal to a number. So this is, the condensing is how you change type number 3 into type number 1, a log equal to a number. Once you have a log equal to a number, what do we do to finish this? Unravel it. What's the base here? 10. So this gives us 10 to the what? So 10 squared equals 2x squared minus 10x. That gives us 100 equals 2x squared minus 10x. That gives us 0 equals 2x squared minus 10x minus 100. Do you guys see I can divide everything by 2 here on both sides? So I'm going to do that to shrink my numbers and make it easier to work with. So that now gives me 0 equals, I'm going to flip everything around so it looks like we're used to seeing it, x squared minus 5x minus 50. What can I now try and do to this to solve it? Factor it. Very good. What does it factor into? Excellent. X minus 10x plus 5. FOIL it out to check it, at least in your head. X and x is x squared. Minus 10x plus 5x is minus 5x minus 50. It works. So if this is equal to 0, then what is x equal to? If this is equal to 0, what's x equal to? Could you get 2 answers to these equations? Sure. Do we get 2 answers here? No, why not? Doesn't matter that one of them is negative. Depends on what happens when we plug it in. If when we plug it in it's negative, we have to throw it out. Doesn't matter that the answer itself is negative. If I plug in a 10, is this guy going to be okay? Is this guy going to be okay? So this one is fine. If I plug negative 5 in, is this guy going to be okay? No. So this one is extraneous. So we cross it out. And so that means that our only solution is x equals 10. Now, if you get 2 answers, are you always going to be throwing one of them out? What if one of them's negative? Are you always going to be throwing it out? No. Depends on what happens when you plug it in. You might throw both of them out. You might keep one of them. You might keep both of them. You might keep the negative and throw out the positive. It depends on what the original looks like. If you had a log of 10 minus x, guys, well, let's do 7 minus x. Would negative 5 have caused a problem on this one? No. You get 7 minus negative 5, which is 12. That's fine. Would 10 have worked? No, because 7 minus 10 gives you negative 3, and we can't take the log of negative 3. So it doesn't matter whether the answer is positive or negative. It matters what happens when you plug it in, as far as the extraneous solutions go. Does that make sense to everyone? So if you guys just identify which of the 3 types of problems you're facing, you'll know exactly how to attack it. Questions about that? Okay. So the homework assignment then, we'll give you some practice on this, and then I'll talk to you guys about what's going to happen the rest of the week, because I'm going to change things a little bit.